is a talk right now, and gee, I've got to think of a band for you too, just to keep the musical thing going. Everyone's going to be rushing for Google for this one. It's a little bit obscure. It's Larkin Poe is my band for the last act of the day. A pair of sisters. They play modern blues, but they get everyone thinking and how tough the world is and how challenging things can be, but at the same time, just getting us all up and energized for being part of it. And I've had one of the duo on the Press 2 for More Information podcast. She is, in fact, the voice talent at the end of every episode who tells you all about Thoughtworks. And look, I won't do a lengthy introduction as to what they're going to talk about today because their passion will show through very quickly. They're both involved in our AI practice and machine learning, come at it from slightly different perspectives, but what they're going to do and talk about today is making it really, really work. And I think that's been an important theme for people today, is to see how this can work back in their workplace. A lot of questions along those lines. It's all very good holding up machine learning and all the magic up there. There's a lot of gotchas. There's a lot of traps. I think it might have even been Harmeet who said, Nigel, machine learning is not for Christmas. That machine learning is not a gift you get for Christmas. It's something like a kitten you're going to own for a long time. And so with no further ado, I'm going to hand over to my two colleagues. Please get active in the conversation, and speaker at the end of it, at 3 o'clock, we're all getting together and you can choose your favorite group to interact with. But right now, all eyes on my two friends, and we're going to talk about data.
Thanks, Nigel. Before I say hi, let's sort out the sharing of screen first. And then, good afternoon, everyone. I'm Harmeet. As Nigel mentioned today, Kiru and I are going to share experiences of machine learning projects in production. When I started as a data and ML engineer, I had a notion and assumption that if my model is perfectly predicting, it's accurate, then the whole initiative driven by that machine learning model would be successful. I focused on getting the right data for it, optimizing the model, getting the right predictions out of it. On the other side, Kiru, who comes from a very strong DevOps and infra background and is considered one of the SMEs at Thoughtworks in this area, was really surprised when she started working on data projects to see that how the operational part, the ecosystem around the machine learning models is underestimated or not paid that much of attention that it needs. Together, we worked on various projects, and we learned that how, if you pay clear attention, or if you apply operational concepts around the machine learning products successfully, how they can be successful. We have seen those projects very, very successful in production when implemented correctly with the operational aspects. So that's where together we believe that we should share our learnings with the wider community, and that's why we are here today. So we are going to, in next 30 minutes, we are going to take you through a journey. In this journey, first we'll tell you how normally the machine learning projects start, and then how they get deployed to production, but then gradually why and how things start failing. But don't worry, we'll also share how to build them right so that the projects, the data initiatives driven by these machine learning project initiatives are successful. And then finally, we'll wrap up with some summary and takeaways and open it up for question and answers. So Kiru, why don't you start with the story of the True Value e-commerce store?
Sure. So though we tell it's a story, so this story is crafted based on our real world experiences, and also like kind of listening to your questions, listening to your thoughts, throughout the day. I'm sure like some of you listening, would also resonate with some parts of the story that we are going to share. So if you have like the True Value, and it started in 2018, so it's a kind of a startup scale up, in the retail market. So when they started, they have this combination of a few brick and mortar stores but they also want to grow big in the digital world. So that's how they started, and it was March 2020, and COVID hit. So they had to close all the brick and mortar stores, and that's the time when they saw this very big, surge, spike in the traffic to the digital platform. So they wanted to make the best use of this opportunity. So they were seeing actually, people coming to their, coming online and, ordering even things like, fresh fruits and vegetables and even everyday items, grocery items online. So they want to kind of give give an amazing experience, to the customer, so that even after COVID, kind of they'll be able to retain, some parts of the traffic. So they did a lot of, different initiatives, and one of the things they would like to, focus and invest is looking at, machine learning models. So they've heard about it. So they've heard about, biggies like, the big players in the retail market, in a lot of use cases where they were successful in using machine learning models, but they thought they're a small player. They're not very tech savvy. They do have like an awesome engineering team, but none of them are experts in, machine learning. So, but they want to kind of start doing an experiment, and the thing they picked is a grocery section. So they see a lot of traffic coming to the grocery, and people buying, small little bundles together. So depending on their cuisine, depending on their, style of cooking, there might be different things, but they see a pattern that if Kiru comes, she always buys a couple of things together, and they see a repetitive pattern there. So they would like to kind of try and see if they can build a simple recommendation model that if I go online and try to buy something, it will show me that if you buy X, so you might also buy, Y and Z. So it makes it easier to build a cart and buy things. So I want to start with the simple experiment for a few different reasons. One, as we saw, like they don't have an expertise in this. And also they do not know if they got the right data. So do they have enough data? Because they thought they're still a small player, new to the market. So they don't know if they have the right data to do this experiment. And also like, they didn't know much about the technology and the frameworks. So they don't have an experience in it. And also from the business point of view, they didn't know how to, measure the value. So they don't know like, how much should I invest in? So that, how much will I get as a return? So they don't know where to start, and they don't know, how much to, go into this. So for a lot of different reasons, they wanted to start as a simple experiment and then build something small and see whether it works, and then, scale based on that. So they want to start with groceries because that's where they see a lot of, traffic coming in, and a lot of diverse set of, new customers, coming in to buy groceries. So they want to build a recommendation engine there. So they, sought help from, data scientists like Jesse and Brad, brought them. So they, spoke about algorithms. So they picked a few. They asked for, a few different data sets. So, the team there made everything available to that small team of data scientists. So they worked on it, and they built a simple recommendation engine. So they tested it internally. So with a few different, personas of people to check if it is actually predicting right. So if I have something in mind, and if I have a pattern, they want the way they tested is it actually showing me what I really have in my mind? So they tested the whole experiment from that perspective internally, and it just worked awesome. So the business, what they wanted to do is, okay, I started as an experiment. Now I have confidence that I can build something. I can really see that it is working. I can see a value in it. So as a very next thing, as soon as possible, I want to pick the thing, which, the initiative, which is built as an experiment, and would like to, deploy it in production as soon as possible. So they just want to kind of, see that recommendation bar coming up in their, website in the grocery section as soon as possible, so that like they want to give that pleasant experience, to the customers. So they took what they built as an experiment and, made it working, run the predictions, more frequently and integrated it. And there you go. So they have that, recommendation bar, coming up in their actual website. So everything was going good. And, the team was excited. They were happy. And they want to kind of, the business was confident that, okay, this is something they could invest in. They could see real value there. And as the next thing, they wanted to expand this to different categories. And with the reason they picked electronics, because this was, they're out in production around, May time period. And for those in Australia, like, the end of financial year sale is very big. And generally, you get a lot of good discounts for electronics. So they wanted to capture, that time period and, expand this recommendation to the electronics section as well. So the team, got started with that piece of work, and they were heads down into it. Then kind of they were, disrupted one fine day. They got a message from a little blue bird where it said that, something is not working in their website. So they see a big black box, ideally, where you see that recommendation. So the recommendation stopped working, and instead you're seeing like, big black box. And someone, tweeted about it, and, it is actually trending. So the marketing team there, picked it up, and they informed the, engineering team, hey, looks like something is wrong on the website. Like, why don't you folks go and have a look? So finally it came to this particular team, like, who was actually, building this experiment, and they were really surprised. So the first thing they did, as we all do, is go and check in the lower environment. So they want to kind of see if actually something is broken. So they want to kind of understand, what's the root cause of the problem. So they went to the lower environment, and they saw like everything was working fine. So that kind of, made them a little more tensed, like, because they didn't know what the root cause, what went actually wrong. Is something wrong while consuming the predictions in the website, or is it not predicting? They're not getting inputs. They didn't really know which step went wrong. So the team tried replicating everything. And then finally they found that there was one particular file which was missing. How we remember initially when we started, the group of data scientists, they requested for a couple of different information. So some of that information was more, real time, flowing every day. But there were also a few different files which are more of a static references. So one such file was that, list of all the products in the grocery section. And, they put that file with some expiry, date, and, say in S3 bucket. And, because of that, the file disappeared. And the whole thing broke, and the error was all the way until the website, and it was picked up by some end user. So they were glad that they found it. So they fixed the problem, and fingers crossed, they were hoping that the black box disappears and things are back to working. But to their disappointment, again, even after they fixed it, even after they added that particular file, still they don't see that recommendation in the website. So they had to go back to the drawing board again, do the entire analysis and see, what is going wrong this particular time. Then they found that, it was a dangling infrastructure. How, like, when we run predictions, you have the infrastructure, so you might be running it on, like EMR, so you'll spin up that infrastructure and then you spin it down after you run the predictions. So they were doing something similar to that. Because things failed yesterday, because of that, there was infrastructure, not cleaned up properly. So they had to go back to it, clean up the infrastructure, and finally, make sure that, things are back and working on their website. So if you remember, like, we had started with groceries, and then the business wanted to do something similar to the electronics, and the team had just started looking into it. So the team had two different train of thoughts. So some of the people in the team thought they could pick the model which they built for groceries and enhance it with the features and make it working for the electronics as well. And there were a few others in the team who thought that they're very different. They could try something completely different, and they want to build a model which is very specific to electronics. So the team actually wanted to do a technical spike and then see what works better. So they went looking for that particular code which was written for groceries, and also the train data which is used for training the grocery model. But all that they could find is that executable object which is there sitting in their AWS environment, and which is what is actually running in the production. So they thought, okay, maybe it is there in somebody's laptop. So they went to the data science team, like the particular team who built that, and they got 4 different versions of it, and they didn't know which particular code and which particular data was actually used, and what is that particular model that they're running in production. So for all these different reasons, they had to leave it there and go ahead and build a new model just for electronics. So they did all that after a few weeks. So they got it working and they got it integrated, and now go to the website, True Value, So you'll see, go to groceries, you say recommendation, you go to electronics, you see a recommendation there as well. But you know how we started talking about this electronics? They wanted to do something for end of financial year sale, because you know that's when you sell a lot of, would like to kind of sell a lot of your electronics and give good discounts. But because of all those reasons where they had to pause and fix things, understand, debug, and then you know fix things, move ahead. So by the time they finish the recommendations, they, you know, it's almost August and you know the sale is gone. But they got it working for the electronics, but unfortunately things broke again with the groceries. But this time around the team was not surprised. They knew that things might break because they pretty much got used to it, that things you know get you know broken every other day. So when they you know made some changes to their inferencing code to include the recommendations for electronics, so they changed a few things and that broke the groceries this time. So like kind of they had to go back again, identify the root cause, try and fix it, and pretty much the team like kind of got used to you know things failing every other day. It was not a surprise to them anymore. And they had this working, and then the business came back and said, this is really awesome, but like we got a few questions. Definitely the sales is increasing, but you know as we know, you know some parts of the world we are like you know got hit with a second wave, and you know we are like back in a lockdown again. So obviously there's like more you know traffic digitally, so people ordering online, things online. So the business did not know if this increase is actually because of those second lockdown in some parts of the world, or is it actually because of this awesome model that we're recommending the right things, that you know people come just buy quickly and you know buy from True Value than anywhere else. So they wanted some statistics around, you know, what is the increase, what is the impact of this model, and you know what's the percentage of increase, and also how they had two different approach for grocery and the electronics. So they wanted to see how do they compare, so which one is performing better, and they want to understand a little bit more about it. So these were like a very good questions. The team would have loved to answer it, but they had no data. They were not collecting any kind of you know information. So they had no way to measure anything. They had no idea how to answer these questions. And also like, you know, adding to this excitement, like kind of they had this board meeting. I was thinking about the investment, you know, where to invest. You know, initially there was some anxiety around how much to invest in this. Now they could see the value, and the feedback from the customers is really good and awesome. So the business wanted to expand this recommendation to all the categories. So they were selling 15 different categories. So I'd like to expand this recommendation to all the categories in their marketplace. But ideally, you know, for a thing like this, the team should be excited to hear this. You know, they built something really quick, started as an experiment. Now it is in production. You know, it's getting really good feedback from the customers. So ideally speaking, the team should be really excited to hear this. But in this case, like the team is feeling like, okay, if they go ahead and expand this, they might end up building more things on a sinking foundation, and pretty much they might end up fixing things every other day, and they don't want to do it. They want to stop here and see, you know, how to, you know, make it right. So when we initially started, you know, how we started with an experiment for a few different reasons. And at that particular time, the focus is all on the model. So whether the model is actually going to predict right. So they tested internally with different personas. This is actually predicting what I have in mind. And, you know, that is the only way they measured that, you know, this initiative is going to be successful or not. But, you know, when we started scaling things, then, you know, the team realized that, you know, model is important, of course, but it is only one small part of it. But there are also a lot of other operational concerns around it, which overall makes this initiative a success. So I'd like to kind of hear from Harmeet, her experiences of, you know, how she would build an initiative like this properly.
Yep. So it seems that from the story of True Value, the model was perfect, but still everything is falling apart. So let's take a step back and see what has happened. What was the first problem? The first problem was that team got to know about the problem when things got out of the hand. World got to know first, and then team got to know. What was the second problem? The second problem was that a simple problem of missing file, finding that sort of issue took a long time for the team. So this says that model was perfect, but there was a system which can monitor the health of the application, the machine learning model is missing. So when you have a perfect model ready, as per your expectation, before jumping into production, see that if you have observability infrastructure available. And we are not saying anything fancy here. Simply start by capturing logs, something where you can capture logs, something in consumable formats. So the log should be in sort of consumable formats so that it can be looked by the team quickly so that they can find the problem fast and then resolve it. And those same consumable logs can be used for alerting so that team gets to know first before the world knows. So start by building a small observability, simple observability infrastructure. Now let's take a next step in the observability or monitoring. Kiru mentioned that when the true value business or CEO asked that how is the model performing, but no one was able to answer. Now this says that they were not monitoring the model itself. So when you have the model ready, start with an evaluation first approach in production as well. So what does that mean? We have a model which is predicting perfectly. What do we want to do with this prediction? We want to control the customer journey. So for example here is, let's say model is predicting that customer would buy some jam, milk, and bread maybe. And we are sending that recommendation to the customer. But is customer actually buying those things or buying something else? So that actual thing that customer is doing is called ground truth. Collect that ground truth, take the prediction, evaluate both of them. When I say evaluate both of them, that is simple comparison between the two, put it to the observability framework that we have so that team or stakeholders can take a look at it and know how's the model performing. And to start with, you can simply start by simple comparison, one-on-one comparison, where you can just say that 10 predictions are correct and 5 predictions are incorrect. And then gradually you can attach ROIs and other things which has value for you to all this framework. Keep enhancing that framework. Now we have observability, we have evaluation. Now let's talk about the sinking foundation. Everything every day was falling apart. So we should build a proper inferencing pipeline so that we don't have a sinking foundation, or if there are problems, we can find them quickly. So let's see. What we have, a great model which our data scientists have created. Awesome. Now what do we need to do to use this model? We need some data. Now, you cannot use the raw data directly. You'll process that data. So process means in machine learning world, we call it feature engineering. Let me give you a simple example. Let's say our model is predicting the probability that customer would buy milk. How much probability is there that customer would buy milk? So what data we need? Let's assume there would be n number of data sets, but one of the data set is the search behavior, the weekly search behavior of the customer. So what we do, we take the weekly data we take the raw analytics data, we filter out the milk data out of it, aggregate the weekly data, and then put it into the model. So this is a very simple example of feature engineering. Feature engineering can be more complex as well. But the focus here is when we are doing feature engineering, what is in there? There are two things, code and data. We are taking code. So the moment we are talking about code, wear a software engineer hat and write unit tests. That's what software engineers have been doing. So data projects are not very much different than normal software engineering projects. Write unit tests. Now, what would unit tests do? Make your code robust, help you refactor and enhance your code in future if you want to, and give you confidence. What is the second thing? Data testing. Now, in data projects, there is a lot of input data sets which are there, and you cannot control what type of data is coming into the source. So you have to have those sort of data set testing. So while writing, you would be assuming that column type, range of values, length of values. So list out all those assumptions and convert them into tests. So that type of data testing is also important to make sure your code is working, your data is working as per your expectation. Now, as this is a code, don't forget to catch all the exceptions and use the observability framework. Why? So that if there is a problem, team can look into the observability framework and find the problem quickly instead of going haywire. What's next? Out of feature engineering, we have a dataset ready, which we'll put into the model and run the predictions. And predictions, once we have run the prediction, while running the prediction, make sure we are catching all the exception, logging all the important metrics, and we all know by now why we need to catch all those exceptions. Then out of those predictions, when we run the predictions, we have predictions. What do we want to do with the predictions? Control the customer journey. Now here comes our evaluation framework that we have spoken about in the last slide. We take the ground truth, put into the evaluation framework that we have, put into the observability framework so that we can take action as and when required. Now, till now, I have spoken about how to fix things or get to know whether there's a problem. But in the true value case, it was failing very frequently. So can we think about the cases where it is where we can stop the failures? We can think in advance. So think about resilience and recovery. So let me give you an example specifically from the data projects perspective. In data projects, you'll be using a lot of data sets. So let's assume here that you're using you're running predictions every day. For everyday predictions, you're using 10 data sets and 10 data sets of a current date. Ask yourself that one day, if one of the data set doesn't arrive, can you manage with the previous day data set? I assure you that in 99% of the cases, you should be able to manage. So think about those sort of scenario and add resilience so that your code your application doesn't fail for every other reason. Add self-recovery. So Kiru gave an example of spinning up an infrastructure. So when you are in cloud, spinning up an infrastructure, you cannot control. There are few things in cloud that you cannot control. There are other vendors. So sometimes while spinning up the infrastructure, there could be problems like cloud is down or something else happened. But these cloud vendors are very good at disaster recovery. So these problems get fixed in fraction of seconds. So have retrials for those sort of scenario so that it gives a retrial again and spins up quickly and doesn't fail for every other reason. Think about build time. So normally what we have seen across the organizations is that machine learning is considered one initiative. That's not the right thing to do. What happens with that kind of assumption is we try to put all the code for machine learning in one repository. With that, what happens? The build time increases. As the build time increases, your developers, data scientists, and data engineers will spend more time in waiting for the builds, and this would increase their velocity, increase their velocity, and decrease the productivity. Think about deployability. Now, deployability can have various meanings, but specifically in machine learning and data projects, what we have seen is either there is no test or development region, or even if it is there, it is very much different. There is no data in development region because when it starts, we directly put we directly start from production and do the experimentation there. And when we come back, we don't have any development region or not similar data in development region. So we get problems like it works in dev, but doesn't work in production. So think about those aspects because it is very important to be successful gradually. Now let's take a breather and see where are we right now. We spoke about observability. We spoke about evaluation. We spoke about inferencing pipeline. Now, what was the other problem in the true value? In the true value case, we had a problem that when team wanted to enhance the grocery model, there was just an object. They were not able to recover the grocery model. Now, this problem occurs because we have been looking at model just an object, what you see on my screen as of now. Instead, what is a model? Behind the model, there is data, there is code, which was used to train and generate that model. So to recover, or I would say to think, when you're thinking about model, putting the model into production, think about reproducibility. When we are thinking about reproducibility, we have to create a training pipeline. So how do we create a training pipeline? We need a lot of data for generating the model, creating a model. What do we do with the raw data? We do feature engineering. It's a similar concepts as we spoke about in the inferencing pipeline. And then when we are doing feature engineering, we write unit test, we write data test, we log all the metrics as I spoke about in the inferencing pipeline. Then out of the feature engineering, we have a feature file. Now let's talk about this feature file. This feature file is the heart of your model. Now in normal application, think about normal software application. Why do we version control our code? So that we can recreate the software application as and when required. One of the reasons is that. Now, if you want to reproduce a model, it's not just code or algorithm, but we'll need the historical data as well. So that we have used to create that model. So if you want to reproduce, you have to version control the data as well. Have data traceability for the data set that is used for the training. Version control them. Now, after the next step, you use that data for the training purpose. And then you create the model. But while the training process, don't forget to log all the training metrics, use appropriate tools to log the metrics and see how your different models are performing and make your data scientist life easier. Now, the next step, or I would say the last, but the not least most important part is model traceability. Now, let me give you an example here. So Kiru spoke about the grocery model and the enhanced grocery and electronic model in the true value case. Let's assume we created a grocery model and then we enhanced it to grocery and electronics model and deployed it to production. But due to some reason, it didn't work very well. And we wanted to jump back to the grocery model. So ask yourself, how quickly would you be able to shift back to the old model or any model of your choice? So if your answer is no, that means your model traceability is not in place. So version control your models as well, because it's very, very important to be to have smooth training pipeline and smooth operational aspect. Now, I've spoken about a lot of things. So let's try to compile everything together. When you have a model ready, a perfect model ready, check whether you have, before deploying it to production, we have a basic observability in place. We have evaluation framework so that we can monitor the model in production. We have an inferencing pipeline so that we can inferencing pipeline with right resiliency, right self-recovery, right test in place. We have a training pipeline so that we can reproduce the model as and when required.
Yeah. So when, how initially when we started, when we spoke about the evolution of, the machine learning product, so the thought process was you start as an experiment because a lot of unknowns. And then the moment, it is predicting right, you're happy with the results, directly we wanted to start, put things in production. But rather, if you want to kind of expand that a little bit and, quickly see, what actually happens before you could actually build a resilient product in production. So of course, like for the experiment, you need to have a business idea, like what do you want to achieve? You need to have an objective, and then you need the right data. And then you could think about, the model. And it is, fairly okay that, some of the experiment might stop here because it may not give you the result that you're expecting, or it's too expensive, or, doesn't have a good ROI. So it's okay to stop there. But, majority of the initiatives might go beyond that, like where you want to, put things in production. So at that point, think about measurability. So when we say measurability, like, how you started with a business objective. So you should be able to pick one or few metrics which are measurable, which will help you understand that business objective. And think about the observability. So again, observability, it's not anything new. It has been, there in the, it's so common in, general software engineering. And like I've been doing it for so many years. And I was really surprised when people come and say that, hey, you don't know, Kiru, this is data project. Data projects are very different. You cannot have observability in data project. Like I clearly do not agree with it because we have done it and, in a couple of projects. So if you hear something like that from someone, like, appreciate that they're from a different, background. So sit with them, help them understand, how they could do it. And think about reproducibility. So will it be like, reliable system in production? And things like this, reliability, like, self-recoverability. So you might actually, learn over time and, mature over time. So you may not be able to think about all possible failure cases on day one, but as and when things fail in production, so obviously your focus is going to go and fix it first, but also pause there and see, is there anything that you could do or improve your code to make it, much more resilient? And we spoke a lot, today about, bias, fairness, auditability, explainability. Think about those things. So I know that there are some industries where there is a requirement from the regulatory authority to explain why you recommended something to this particular, person. But it's also just a fairness to understand that, you don't have a bias in your own prediction. So you should be able to explain why you're predicting X, for this particular data set. And, ensure that what you're going to build, it's going to evolve over time, because your data set might change, your, input customers might change, the persona might change, your business model might change. And of course, you want to improve your code, the way you inference, the way you integrate it with your, wider ecosystem. And last, but the most important part is to think about the collaboration, because we have seen this enough number of times where this is, thought of as a siloed, process, siloed approach, where you have a small dedicated data team who will go ahead and do this on their own. So it is okay to start like that when you're experimenting initially. But when it comes to a point of actually scaling, integrating with your ecosystem, think about this as a, your org-wide, capability. Think about how to, enable that team to understand your business, understand your product. So you need to have that collaboration of engineers plus DevOps skills, plus your business, your data engineers, and your data scientists. And this would kind of take different form and shape over time. So initially when I started, we thought like, model might be great. Like the model was predicting very accurately what I had in mind. But even if model might be great, it could happen that, the other things around you might fall apart. And those are the things that you need to keep in mind, that, when you're building an initiative, what else you need to think, beyond the model. And maybe like interest of time, we'll just like kind of, share the slide over Slack, but this talks a little bit about the different tools that you could use, across these stages. So this is like a snapshot of it, but also would like to hear from you folks. If, you people are, into, this machine learning initiatives, we'd also love to hear what kind of tools you're using, what works for you, what did not work for you. And just want to highlight that, especially this particular, tool set, this particular area is like, emerging very rapidly. So if you're into this, keep an eye for it. There might be a tool which gets mature. There might be a new tool which might be coming up. So I'd say like, keep in touch with the community. And initially when I started preparing for this talk, like we just wanted to talk about so many different things. So we started capturing our ideas, and we want to capture like, okay, the moment you start, the build and all the way to testing it, deploying it, putting it in production, operation mode, and then evolving. There's so many different things that you need to do and, keep in mind. So we kind of captured all our thought process, but you could talk about, only so many things in 30 minutes. So we just wanted to leave you with a snapshot of what are the different things that you would do all the way from build, to deploying your initiatives, ML initiatives in production. So feel free to have a look at this. I know it's not readable, don't try to read it here, but we'll share a copy of this on Slack channel, and hope to kind of discuss with you folks there and see, how things are working for you. And thank you so much for your time today.